Alright, hi everyone, welcome to my YouTube channel, City of Electrons. So in this video, we are going to work an example from what we talked about in the previous video. Okay, that's we are going to consider. We are going to consider a differential equation. Now, of course, remember to comment, like, share, subscribe. Comment especially. Now, observe this that was done in the previous video. And I said, I explained this in previous video. But guys, this is M, and just like that. Okay, but guys, why is this N? No way, that should be M, yo. That should be M, bro. Okay, yeah, that should be M, just to be consistent. Okay, if this is M minus 1 and this is M, of course. So we are just giving like different side. That is this side, the input side, we are just using N for it. Output side we are using N for it. Input side we are using M for it. We can actually use same letter, N here, N here. After all, we call this nth order differential equation, right? That's what we call it. That's what we named it. But those are just notations. Okay, so let's continue now. But before we look at the example, look at this. Note that the transfer function here is written in the S, or we say frequency domain. Y of S, X of S, H of S. Look at the Y of S. But in our equation here, we have Y of T, not Y of S. That is, when you take the Laplace transform of Y of T, we are going to have it in S domain, not in T domain. T domain is time domain. S domain is a frequency domain. Okay, so in case you are not too clear with what I just said, no problem. As we keep solving, you will get to understand what we mean by frequency, by the S domain, and why are we taking it there. Or let me just quickly say it. Why we have to take this expression, take the Laplace transform of this equation, take it to the S domain, is so that you can use simple algebraic methods to simplify the equations, to simplify and get what Y of S is. And then when we have Y of S being simplified, we can take the Laplace inverse. Laplace inverse, that is to return from the S domain to time domain. Okay, I think I said something like this in the previous video. Yeah, I did. Alright, so let's go. Consider the second order differential equation. Second order meaning the highest power or the highest derivative is of order 2 or of power 2. So look at it now. 2 dots, dot dots. So Y of T, A1, Y, this A is a constant, of course. Y dot of T plus A0 and everything like that onto the B side, so you can see everything. Okay, I don't need to read the whole thing, you can see everything. Now for T greater than or equal to 0 with initial conditions, that means Y dot of 0 equals 1, Y of 0 equals Y0, X of 0 equals X0. Now what's the meaning of all this? Like, what's this? We can't even see this in this equation. Okay, is there anything like Y of 0? There's something like that here. Now these things, these conditions will be useful when we take the Laplace transform. So the main question now will be, how do I take the Laplace transform of this? So thank God we are here in this video. We are going to do that. How to take the Laplace transform of this. Now in case you've done Laplace transform before, that's fine. If you've not, that's also fine. Okay, you get to know enough Laplace transform you need for this video or for this example. Okay, so now we are asked that, or it said that the equation can be written as this. Of course, I said this in the previous video. Okay, this is same as this, and this is same as this, and this same as this. Okay, I said this in the previous video. Now let's go to the solution. Solution: using Laplace transform to solve the differential equation, we have Now, this is exactly the question, just that I put them in brackets. Okay, I felt like I should write this in real time. Well, I solved the whole thing before making the video, so as to save time. Alright, so let's go. So L just means Laplace. Okay, just means we are taking a Laplace transform. But if you see this, it means you are taking the Laplace inverse. But seeing this just means you are taking a Laplace transform. And then we'll put this symbol. We'll put this symbol. So whatever we are taking the Laplace transform of, that thing will be inside this symbol. So this expression we have here, this expression, I think I should copy it out. This expression we have here, good. And put it somewhere close enough we can easily see and make reference to it. Good, that's close enough. Now, excuse me, take this out. Let me just delete these guys all together. Okay. Alright, now the thing is this. Are you seeing the first term here? The first thing here. Take the Laplace transform of it, just like what I said. You put this L, and then what you are taking the Laplace transform of will be inside the square bracket, curly braces. So you have this guy inside the curly brace, and you have the L outside. Now all constants will be taken out. You are not taking the Laplace transform of a constant. Okay, so you have L, that's Laplace transform now of this guy. The A will be outside the Laplace transform, so we see it here, this sign, look at it here, the A is outside. Plus the next thing, A0, we have this value here, y of t, A0, y of t will be inside the curly brace. Okay, that's for that. Then the next, we'll go to this side. Of course, this constant, or coefficient rather, whichever one, the coefficient will be outside, and we have this thing inside the curly brace with our Laplace transform there, plus b of 0, of course, that will be outside, and then we'll take Laplace transform of this. So this first line, I hope we are clear with this first line. Okay, now taking the Laplace transform, there is a pattern I want to show you that will help you recall how to do or what happens when we take a Laplace transform. Now when you take the Laplace transform of this second derivative, this is what happens. Now how many dots do you have here? 2. So you start like this by saying, let me put it this way, you start by saying S. How many dots you have on top there? 2 dots. So you have raised to the power of 2, and then Y, this is the Y, this Y now, but this guy will become S, because we are going to the S domain now. Here become S. This is the first term. We are not through with this guy, we are still working on this guy. Then you now say subtracted, or you subtract the next thing from it. This S is going to drop. Okay, this S is going to what? Drop, meaning it will now be S with the power of 1. Then we now have Y of 0. Then we are going to have what? We are going to have it like this. Okay, Y of 0 without a dot. Okay, then the next thing that will happen is this. We have Y, let me put it this way. We are going to have S with power of 0, and we are going to have Y dot of what? 0. But we all know that anything raised to the power of 0 is what? 1. So that guy is gone. Okay, so since we don't have any other S again, we are not going to do anything. We stop here. So this will be it. Okay, however, with assuming we are giving that this is Y dot dot dot, we would have begun with S to the power 3. It would have been something like this. Let me use as an example, assuming we had that. There are 4 dots now. So assuming we had 3 dots instead, okay, it would have been this. It would have been this, saying s raised power. Let me put that somewhere safe for the eyes. Assuming we had 3 dots, it would have been s raised to power 3 y of s minus s raised to power 2. Then we'll now have, this will become, no, the first one doesn't have a dot. The first y0 has no dot. Then we'll now have s. Then we'll now have dots. Then we'll now have minus y dot dot 0. Are we seeing the process now? Okay, if you understand this first one I'm talking about now, it applies to the rest. So this is the case where we have just 2 dots, dot dots. This is how it will look like. Okay, and if we have 3 dots, this is how it will look like. The thing is that s begins from the highest, and the highest power of dots is from s. The highest power of dots gives us the power of s, and it begins to reduce. S raised to power 3, s to power 2, s raised to power 1, s raised to power 0. Therefore, for y, it's start with just y of s. This guy becomes s, and you now have y0 without a dot, y0 with 1 dot, y0 with 2 dots, just like that. Okay, so back to the equation. Okay, so now we can see that since we have 2 dots, we just use this, and then it goes down, and for this guy, from this point we have no dot here, it increases to 1 dot, and so on. Okay, now this is what I talked about in the equation. Now they've said that y dot of 0 equals y1. So look at it, y dot of 0 is y1. Are you seeing it now? Then y of 0 is y0. Let's come and look at it here. So y of 0 is y0. Okay, I hope that's clear enough. I think I should just add this to my solving here. It should be, let me put it here so we all can see what's going on. Alright, now let's continue. So the next thing will be this a1. So taking a Laplace transform of this now, so what do you think? We have just 1 dot, meaning we start with just s like this, and then y of s minus what? y0. Okay, so since we have no more s, we'll stop there. So this will be it. Okay, plus, so we're done with this guy, plus a0. Now taking a Laplace transform of this, do we have any s? Of course not, we do not have an s here. The only thing we have here is y and then t, so we have the t becomes s. So the only thing we have here is just what? Y of s. That's all we have here. So we are not going to do any other thing here because there's no s here. And that's that, and this equals b1. So now let's see the Laplace transform of this. So for this, we have what? 1 dot. Yeah. So we're going to have an s, and then x of s minus the s goes away, and we have x of s like this. No. X of s, no, x of 0. Same pattern with what we've been doing so far. X of x0. Okay. Plus b0, taking the Laplace transform of this there is no dot, so we are doing just 1. You are doing just x of s. Okay, good. So now we can see that we finally have these terms. Y dot of 0, we have it here. So everywhere you see y dot of 0, you put y1. So look at it, y dot of 0, y1. Any other y dot of 0? No. Anywhere you see y of 0, put y0. Y of 0, put y0. Y of 0, put y0. No other y of 0. Anywhere you see x of 0, put x0. Or x0 to draw x of 0, put x0. No other one again. Okay, so this is how we arrived at this point. This is how we arrived at this point. Okay, so from here, from this line down, all we did was just to simplify so that we can have y of s, which is the output signal but in the s domain, have y of s on its own, and then x of s also on its own, which is the input signal, of course in the s domain, also on its own. Just simplify. Okay, of course you can do that, but I will go into it, like explain the step-by-step simplification until we get to this point in the next video. But of course you can just take a screenshot and go through the process. Okay, you can take a screenshot and then go through the process, look at the simplification, but I'll talk about it in the next video. Okay, so like, share, subscribe, comment, and I hope this helps, and I'll see you in the next video. Thanks for watching. Bye for now.